It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, welcome to lesson 15 here, where we're going to start dividing polynomials again, but this time there's going to be a remainder. So like we did in fourth grade when we divided, sometimes we ended up with remainders. Things didn't divide in evenly, as we used to say. So we're going to talk about what happens with polynomials, and it's going to have major implications for graphing and all this good stuff. So let's start it off by computing 1,355 divided by 4. Let's take a nice trip back to fourth grade, fifth grade. I don't know when we do remainders, probably fourth grade. I'm going to divide this number by 4. So, all right, 3 times 4 is 12. Subtract. 3 times 4 is 12 again. Subtract. 8 times 4 is 32, which leaves me with a remainder of 3. So my quotient is 338. My remainder is 3, and I have a remainder of 3 because my divisor can't divide that. My divisor of 4 can't divide that. So the way that we write our answer, 1355 over 4, is really equivalent to our quotient plus I still have 3/4 left over. It's 338 plus remainder over divisor, remainder over divisor. That's how we're going to be writing our answers. Quotient plus remainder over divisor. That's how we're going to be writing our answers when we work with polynomials. So let's slide down to 2 here. We're going to skip question 1, and let's slide down to 2 where I'm going to divide this using the reverse tabular method and long division for both of my folks out there, depending on what method you like. So let's do reverse tabular first. So I'm going to divide by x plus 5. Hopefully this is a good review of division because we haven't done it in a while. All right, then I've got x to the third, 2x squared, 8x, and 1. So I'm going to push in x to the third and ask myself, what times x is x to the third? Well, x squared, which gives me 5x squared, but I don't want 5, I want 2. Well, what in 5 makes 2? -3. -3 times x is that. -15x. All right. Well, I'm at -15. How do I get to 8? Well, I need to add on 23, I think, right? 23 minus 15 is 8. So I'm going to put a 23 up there, maybe. 23 times 5 is 115, but I need 1. So notice that that last box isn't matching up like we're used to having. So what this tells me is I have a remainder. I kind of have another box here. What's my remainder box? Well, what in 115 makes 1? What plus 115 makes 1? Well, -114 is my remainder. -114 and 115 makes 1. So my answer, my final answer, is x squared minus 3x plus 23 plus my remainder divided by my divisor, whatever I divided by. Quotient plus remainder over divisor. And now I'm questioning if I did this right, but I'm sure if when I do long division, I should be getting the same exact answer. So reverse tabular method, you got to do a little bit of thinking here where you have that magic floating box to give you your remainder. You're at 115. How do you get to 1? You need to subtract away 114 to get to 1. So that's your remainder. Whatever number you have to do there, that ends up being your remainder. Let's do some long division for my couple long dividers out there. I'm here for you too. So we get x squared times x is x to the third, x squared times 5 is 5x squared. We change our signs to subtract. -3x squared plus 8x plus 1, and we start again. -3x squared, -15x, Change our signs to subtract. We end up getting 23x plus 1. All right, this is looking good because all these numbers look familiar to me because I just did this exact problem in a different way. 5 times 23 is 115. Change my signs to subtract, and I end up getting negative 114 as my remainder. So what I like about long division compared to reverse tabular, the one thing I do like about long division is it clearly tells you what the remainder is. You don't have to think. There's no thinking to find your remainder here. Long division just tells you what your remainder is. But again, you write your answer the same way. Quotient plus remainder over divisor. Quotient plus remainder, and just the remainder is divided by the divisor. And that's how we're doing this. That's how we long divide. We can long divide polynomials, and our answer doesn't end up being a polynomial because we have that fractional piece left over. But it's pretty much a polynomial plus some little fractional piece that we're stuck with. So I got some practice problems here for you. Try them as we go, and we'll see how we do. So x cubed minus x squared plus 3x minus 1. So we're dividing by x plus 3. I've got x to the third. Negative, I'm going to put a negative 1 there just to remind myself that's a negative 1. A lot of people sometimes confuse that with 0. So x to the third. Well, what times x is x to the third? X squared. X squared times 3 is 3x squared. What plus 3 makes negative 1? What plus 3 makes negative 1? Well, I believe that would be a negative 4. So I'm going to put a negative 4x up there, which gives me negative 12x, but I need 3 of them, so that means I need 15 more of them there. 15 minus 12 is positive 3, good. And then finally, I can put a 15 here. 15 times 3 is 45. So you got to be careful. I'm at 45. How do I get down to negative 1? You got to be careful. A lot of people say 44 here, and that's not right. I need to subtract away 46 as my remainder. 45 minus 46 gives me negative 1. So my remainder is negative 46. Again, that's not my answer. My answer is the quotient. Let me change colors here. The quotient plus the remainder over the divisor. That right there is my final answer. Quotient plus remainder over divisor. Quotient plus remainder over divisor. You're going to be hearing me saying that a lot. Quotient plus remainder over divisor. The key thing is here, folks, when you need to figure out, I'm at 45, how do I get to negative 1? I need to subtract away 46. There's that mental math piece that I need you to kind of think about and pause for a second. All right, I'll do a long division for my long dividers out there. I've got x minus 8, and I'm dividing x squared plus 4x plus 10. So what times x is x squared? Well, x squared minus 8x. Change my signs to subtract. 12x plus 10 plus 12. 12 times x is 12x. 12 times negative 8. Oh boy, 12 times negative 8, I believe, is negative 96. But then we need to change our signs to subtract, and we end up with a remainder of 106. So my answer, this quotient equals x plus 12, that's my quotient, plus 106 over x minus 8. That right there is my final answer. Quotient plus remainder over divisor. All right, couple more to go here. I'll do a reverse tabular again. I'll do another reverse tabular. So 2x minus 5. And I'm dividing away. 4x to the third. Ooh, warning, 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 warning. I need a placeholder there of I have 0x squared. So make sure you caught that. Make sure you catch that one there. All right, here we go. We push that first term back in. We push that 4x to the third in and get started. What times 2x is 4x to the third? Well, 2x squared. Multiply. I have negative 10. I need to get to 0. So 10 minus 10, that's not bad. And we start again. What times 2x is 10x squared? It's 5x. Get negative 25, but I need positive 5. So if I'm at negative 25, I've got to go up 30 floors to get to positive 5, which leaves me with a 15, negative 75. Oh, this is tough here. I'm at negative 75. I have to end up at negative 8. I'm at negative 75. So maybe it's helpful to write a little equation. I'm at negative 75, and I need a remainder to get me to negative 8. It's kind of a little equation you can solve. Negative 75 plus r gives me negative 8. So if I add 75 to both sides, that gives me my remainder of 63. Positive, I need to go up 63 floors. So my answer is 2x squared plus 5x plus 15 plus 63 over 2x minus 5. That right there is my quotient. So the key thing is here, this remainder step gets a little tricky because you got to do some mental math, but you can think of it as an equation. This box plus r equals whatever came out from the arrow. Box plus r equals the arrow. All right, I'll do another long division, another reverse tabular, since that's a majority of you use. I will follow the will of the majority. 2x to the third, negative 4x squared, negative 7x, and negative 10. So we get 2x cubed, so 2x squared. Gives me negative 10x squared, but I need negative 4 of them. I believe 6 minus 10 is negative 4. Nope. So plus 6x up top, which gives me negative 30 here. I'm at negative 30. I need to get to negative 7, so I'm going more positive. I'm starting at negative 30. I got to climb up to negative 7. Climb up 23. I'm at negative 115. Negative 115 plus a remainder has to give me negative 10. Box plus r equals the arrow there. So I add over 115 and get a remainder of 105. I get a remainder here of 105. So my final answer, 2x squared plus 6x plus 23 plus remainder over divisor. It's basically a polynomial plus that little fraction added on, which doesn't make it a polynomial in the end. 2 more and I'm done. 2 more and you're done too, until you do those 2 problems for me on the Google form. Ooh, we got to be careful here because I'm dividing by x squared, 0x, and negative 1. So that's a little weird here. From that box, I get 4x squared. What comes after 4x squared? A warning, 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 a negative 0x. This is a really weird problem. This is a really weird problem because I just need one column. I just need one column, and I've got everybody covered here. So I'm going to push in 4x squared and say, what times x squared is 4x squared? Well, 4. 4 is literally the quotient. That is it. That is my quotient there. And my remainder is negative 1. Negative 1 minus 1 is negative 5. So this is a really weird problem because the answer is 4 plus negative 1 over x squared minus 1. Quotient plus remainder over divisor. That's a really weird one. Those are kind of the ones I skipped in the beginning, but notice that you can do it. It just looks weird. And finally, my last one here. So I'm dividing by x plus 2. I probably should have made that box a little bigger because I got to the 4th power. So I got x to the 4th. Who comes after x to the 4th? Well, 0x to the 3rd. Negative 8x squared. I have 0x's next. Gotta watch out for those placeholders. They sneak up on you. And then a positive 12. I don't know why mine didn't type there, but positive 12. All right, here we go. X to the 4th. Gives me x to the 3rd. 2x to the 3rd when I multiply down, but I need 0, so I need negative 2 of them. So negative 2x squared gives me negative 4x squared here, but I need negative 8, so I'll go more negative. I'll go negative 4. Negative 4, negative 4 make negative 8. We can start again. Sorry for the yawn. I'm tired. So are you. I have negative 8. I got to get to 0, so I need positive 8. Ooh, I get 16. I get 16 there. But I need 12, so that tells me I have a remainder of 16 plus what is 12? I have a remainder of negative 4. So my final answer here is quotient plus remainder over divisor. Quotient plus remainder over divisor. And I'll see you guys in the next lesson.